In this lesson, which is our follow-up lesson on constructing sign charts, we're going to look at 3 examples, and for each of them we're going to construct sign charts for that expression. So rather than write it out every time, I'm going to say construct the sign chart for each of these expressions. All right, so for our first example, we're going to look at x cubed plus 5x squared minus 4x minus 20. Okay, and then for our next example, so let's draw a nice neat line down the middle here. For our next example, we're going to look at x plus 5 quantity squared times x minus 7. And for our final example for this video, we're going to look at x plus 4 over x minus 3. All right, so I hope that you're already looking at this thinking, okay, there's some new stuff here, right? The first one is not pre-factored, so we're going to have to do some factoring to see critical numbers. The second one has a square in it. That's new. We haven't seen that before. And the third one is a quotient. All right, so here we go. So for this one, we still need to find the critical numbers, which was really convenient to do in the last video because everything was pre-factored. Here, we're going to need to factor. And what I hope you remember from our lessons on factoring is that this seems very conducive to factoring by grouping. You have a 4-term polynomial. It seems like the 2 and 2 grouping is going to work. Or at least it seems like it would be worth trying. So let's try the 2 and 2 grouping. All right, here we go. So for the first 2 terms, we have x cubed plus 5x squared. We can factor out x squared, and we're left with x plus 5. So again, I'm taking these first 2 terms, and I'm factoring out x squared, which leaves me with x plus 5. Now, my second group, remember we talked about this, my second group leads with a negative, which means that whatever else I might factor out, I'm also factoring out the negative. So I'm going to factor out negative 4. And sure enough, when I divide negative 4 out of negative 4x, I get x. And when I divide negative 4 out of negative 20, I get plus 5. So remember we talked about how this is sort of the look of a successful grouping. That both of your groups end up having a thing in common. So we can pull out the common factor of x plus 5. Okay. And we're left with x squared minus 4. You could stop here and find the critical numbers now, but I recommend trying to factor it all the way. So as you might remember, we mentioned this briefly. X squared minus 4 is a difference of 2 squares. So x squared minus 4 will factor further into x plus 2 times x minus 2. And I think it's handy to take it down all the way. All right, so now down to critical numbers. So remember, we're going to set each factor to 0 and see what x has to be. So x plus 5 is 0 when x is negative 5. X plus 2 is 0 when x is negative 2. And x minus 2 is 0 when x is 2. All right, we're going to do exactly the same thing that we did in the last video. So we're going to build up. We're going to look at the sign chart for x plus 5. We're going to look at the sign chart for x plus 2. Multiplication is commutative, so the order in which you do these does not matter. So we'll build up sign charts here. And then at the end, we're going to do the sign chart for the whole product. Just to keep my work from looking too claustrophobic, I'm just going to write the purple line underneath. And I'm going to know, based on my color coding, that the purple sign chart is the one for the whole product. But I'm not going to write the product there. You should in your notes. I'm not going to write it there just to save a little bit of space. Okay, so here goes. The critical number that came from x plus 5 is negative 5. The critical number that came from x plus 2 is negative 2. And the critical number that came from x minus 2 is positive 2. So now let's kind of bring them down. Okay, so there they are on what will soon be our final sign chart. Okay, now here we go. X plus 5. If you look at values of x that are to the right of negative 5 and you plug them in, you're going to see that x plus 5 is positive. If you look at values of x to the left of negative 5 and you plug them in, you'll see that x plus 5 is negative. Again, that's a pattern we're starting to see form, and it'll work a lot of the time, that for values of x that are to the right, x plus the value is positive. For values of x that are to the left, the value is negative. But don't get so comfortable in that you cannot deal with it being different, because in the very next example it's going to be different. All right, for x plus 2 though, it's not different. For values of x to the right of negative 2, x plus 2 is positive. For values of x to the left of negative 2, x plus 2 is negative, and the same is true for x minus 2. To the right of 2, x minus 2 is positive. To the left of 2, it's negative. If you do not follow what I'm saying, if you're thinking, my gosh, I'm overwhelmed right now, pause the video and plug in some values. Plug in some values that live to the right of negative 5 to x plus 5. Plug in some values for x plus 2 and x minus 2 to start to believe that, okay, when x is to the left of 2, x minus 2 is negative, and so on. You have the pause button. Use it. All right, off we go. So now we're going to be putting this together. We kind of already did this before, so it will probably be going a little bit more quickly. The leftmost region, we have 3 negatives. You'll remember we talked about what happens when you multiply 3 negatives together. You get a negative. The next region, you have 2 negatives and a positive. We already discussed how that works. 2 negatives and a positive multiplied to a positive. Next region, 2 positives and a negative. That multiplies to a negative. Last region, 3 positives. They multiply to a positive. So there is my sign chart in purple. Let's move on to our next example. So for our next example, we have x plus 5 squared. This is our first example of a square. I'm going to give you what I will frequently do kind of as a you could. You could generally means that some will find this a little bit more explicit, a little bit more clear, but it takes longer and it's not something we want to settle into as like our permanent approach. You could think of x plus 5 squared as x plus 5 times x plus 5. So really kind of approach this as an expression with 3 factors, build 3 of the kind of build-up sign charts. You can do that if you want. I'm actually not going to do that, so I encourage you to try this on your own if you feel like it might be helpful to you, and then bring questions to office hours or our class meeting. But I'm going to treat x plus 5 squared as its own factor. So remember, for first thing we always do is we think about critical numbers when we're constructing a sign chart. And critical numbers ask, when is this expression equal to 0? So zero product property. When is x plus 5 squared going to be 0? When x is negative 5. When is x minus 7 going to be 0? When x is 7. So I'm mostly just going to march on. So as I said before, I'm treating x plus 5 quantity squared as its own factor, not breaking it up into 2. And I'm treating x minus 7 as its own factor. So I kind of have two factors here, even though nominally one of them is kind of 2 packaged into 1. And then again, I'm going to use my color coding to tell myself that the product is in purple. All right, here we go. The critical number that came from x plus 5 squared was negative 5. The critical number that came from x minus 7 is 7. So let's trace them down. Now, you'll notice that I left a little bit of a blank space here, and that was for a reason. And that reason is I want to introduce you to an idea. So, hugely important idea. X plus 5 squared is non-negative. So that's a really big term here, all right? X plus 5 squared is non-negative, meaning there is no value of x, or I should say no real value of x, that you can plug in that would make x plus 5 squared be negative. And this is going to play a huge role in the sign chart, okay? All right, so here we go. Just like I just said, x plus 5 quantity squared is incapable of being negative. Whether you're plugging in values that live to the right of negative 5, or you're plugging in values that live to the left of negative 5. When you go to square, you always end up with a positive number. So x plus 5 squared is positive everywhere except for negative 5, which is where it's 0. That's why we call it non-negative, because it can be 0, it just can't be negative. X minus 7 is back to being garden variety, right? It's positive when x is to the right of 7, and negative when x is to the left of 7. So in this problem, we kind of have one of each. One comfortable factor, like we've worked with many, many times, x minus 7, and one new one, x plus 5 squared, which is non-negative, and that doesn't follow that same pattern where for values of x to the right, it's positive, and for values of x to the left, it's negative. So watch that, like that's an important moment here. The rest is actually fairly familiar, right? So we're going to go down the list and combine. So in the first region, we're going to multiply together a positive and a negative, which is negative. In the second region, we're again multiplying a positive and a negative, so it's still negative. And in the last region, we're multiplying two positives together, and we get a positive. So I'm not going to make a huge deal about this now, but I do want to sort of call your attention to the fact that negative 5 was the critical number that came from the non-negative factor, and there was no change of sign around the negative 5. If you compare to the previous example we did, right? None of our factors were non-negative. X plus 5, x plus 2, x minus 2. None of those were squares. And when we looked at the final sign chart, the sign goes flip, flop, flip, flop. It changes every time we pass through a critical number. But that doesn't happen here when we have a critical number that comes from a non-negative factor. So that's very curious, it's very important, and we'll say more about it later. The last example I'm actually going to almost whip through, and it's really just there to implant the idea that products and quotients are cousins, and when it comes to sign charts, constructing a sign chart for a quotient is exactly the same as constructing the sign chart for a product, okay? So for critical numbers, this is the only part that might feel a little funny. We want to know where both the numerator and the denominator pass through 0. And the reason that that might feel funny is that we probably know somewhere deep in our souls that denominators can't be 0. You can't divide by 0. And so that's where it's really important to remind yourself you're not solving anything here, you're just cataloging signs. So since passing through 0 is the gatekeeper between being positive and being negative, we need to keep track of where that gatekeeper is for both the numerator and the denominator. So critical numbers are going to come from both the numerator and the denominator, which means that they are -4 and 3. From there, it's going to feel very familiar, like almost eerily so. Like, wow, it really isn't any different. As far as constructing sign charts goes, quotients and products are nearly identical. There are differences when you're solving inequalities with quotients versus products, and we will get to those, but not for constructing sign charts. All right, so we have a critical number at -4. We have a critical number at 3. Let's map them down and up. And you'll notice from here, it's going to feel really similar to the very first example we did. X plus 4 is positive for all real values of x that are to the right of 4, and negative for all real values of x that are to the left of 4. Same with x minus 3. It's positive for all values of x to the right of 3, negative for all the ones to the left. And now we're going to put them together. 2 negatives multiply to a positive. A positive and a negative multiply to a negative. 2 positives multiply to a positive. So this concludes this example for the quotient. You'll notice it went very quickly. And what we're going to do in our next lesson is we're actually going to start solving some inequalities using sign charts. I want to stress that as the final thing I say here. All we've done in this example is construct sign charts. We haven't actually used them for anything. So the next couple of lessons, we're going to talk about, hey, once you have a sign chart, what can you use it for? Stay tuned for that. Enjoy.